Although the Federal Reserve has a lot of control over the money supply, most of the money that's out there is created by banks. And the process by which banks create money is nothing short of magic. To understand the way banks create money, remember that bank reserves put a limit on the number of new checking accounts that banks can create. Anytime a bank makes a loan, the bank makes the loan by creating a checking account. That is, the loan is an asset of the bank, money that's owed the bank, on which the bank is earning interest. And the checking account is a liability. The Federal Reserve watches checking accounts because they're part of the money supply, part of what people use to go shopping. So there's a restriction on the creation of new checking accounts. And that restriction is that for every new dollar that banks create in checking accounts, they have to have reserves equal to 10 cents. And reserves have to be held in the form either of cash or reserve deposits, that is, the bank's own deposits at the Fed. Now, once you understand that there's a reserve requirement, the process by which banks create money becomes very, very interesting and ends up with the concept that we call the money multiplier. The money multiplier explains how a little bit of action from the Fed can create a lot of new money in the banking system. Let's see how it works. Suppose you, a securities dealer, decides to do a transaction with the Fed. You sell a security to the Fed, and the Fed gives you a check. Now, you take that check to your bank, and let's suppose your bank is called Bank A. Let's look at how the deposit of that check shows up on the bank's balance sheet. Here on this T account, I'll put bank assets on the left and bank liabilities on the right. Suppose the check you deposit is for $1,000. Well, the first thing that happens is the bank has a new liability. That is, the bank owes you $1,000, which is the amount of money that you put into your checking account. And we're going to call you person number 1. When the bank takes the check that you deposited and presents it to the Fed can do one of two things. Either the Fed can give the bank cash, or the Fed can give the bank credit in that bank's reserve account at the Fed. Either way, Bank A winds up with an increase in its reserves of $1,000. So the $1,000 checking deposit winds up as an increase in bank reserves because it's coming from the Fed. The bank takes the check to the Fed and gets reserves in exchange. Now, the bank has some thinking to do. It's got $1,000 in reserves, but only 1,000 new dollars in checking. So, since the bank only needs to hold a fraction of this as a legal reserve requirement, it can lend out the rest. And let's see how the bank does the calculation. The bank says to itself, we got $1,000 in new checking times a required reserve ratio of 10% means that we've got to hold $100 as required reserves. That means that if we subtract that $100 from our $1,000 of reserves, $900 of that reserve is lendable. And the bank, by golly, is going to lend it out as soon as it can because it's only the loan that earns interest. The reserves earn no interest. So the bank very quickly makes a loan, and that's going to increase its loan portfolio by $900. So $900 in loan is created, and the bank creates the loan by giving somebody a new checking account. Let's say Jane comes in and she wants to expand her bakery, and she needs to buy a new oven that costs $900, so she borrows the money from the bank. The bank gives her a checking account, and she writes a check to the appliance company that brings the new oven to her store. Now, what happens when that occurs? Jane withdraws the money from her checking account, so her checking balances of $900 are drawn down to zero. Meanwhile, the bank that the appliance company uses brings Jane's check back to Bank A and wants to clear it somehow. It can either be cleared by giving the new bank cash or by giving the new bank $900 worth of Bank A's reserves at the Fed. Either way will do. Whatever happens, Bank A winds up with $900 less in its reserve account than it had before. Now, let's look at what's happened on net here. After all the dust has settled and Bank A has done its business, the net result is that $1,000 in reserves came in, $900 in reserves went out. The net increase in reserves at Bank A is $100. Meanwhile, Bank A has had a net increase in checking deposits of $1,000. It created an account for Jane, but Jane withdrew it immediately, leaving your account as the net change in checking, $1,000. And if we take the ratio of the change in reserves to the change in checking, that ratio is equal to 10%. We say that Bank A is now loaned up because they can't legally make any more loans without violating their reserve requirement. But notice, the interesting step is this step right here. This is the step where Bank A created money. That is, Bank A created money that didn't exist previously just by the stroke of a pen. By making a loan to Jane and giving Jane a checking account, Bank A created new money. And this money is added to the money supply. I'm going to set this money aside because in a minute I'm going to ask how much money is created in total by the time we reach the end of the story. So we'll put the money created by Bank A over here on the side and bring it back in a minute. Meanwhile, let's follow this $900 in reserves that left Bank A and wound up at Bank B, the bank of the appliance dealer from which Jane bought her new stove. Let's consider how that works. The appliance dealer brings in a check from Jane for $900. And the appliance dealer we're going to call person number 3. Well, Bank B took that check to Bank A, as we saw before, and acquired $900 in new reserves. Well, now Bank B has a calculation to do. Bank B asks itself, how much of this money do we have to hold and how much of it can we lend? Well, our new checking account is $900. So 900 times 10% is $90. It takes $90 of reserves to back this checking account. Subtract 90 from 900, and that means that Bank B can create a loan equal to $810. And Bank B is eager to do that as soon as it can, so it doesn't lose a moment's worth of interest. So let's suppose Jack comes in, and he wants to take a vacation, and he's going to borrow money from Bank B. So Bank B creates a checking account for Jack. He's person number 4. And what happens next is Jack takes his checkbook to his travel agent, writes a check for $810. The travel agent presents the money to his bank. His bank shows up at Bank B and wants reserves to clear the check. So $810 worth of reserves flow out of Bank B to make Jack's check good. Well, what's the net result of all this action at Bank B? The net result is $900 worth of reserves came in, $810 flowed out to clear Jack's check, and the net change in reserves is $90. The net change in checking is that $900 that the appliance dealer brought in. And the ratio of the change in reserves to the change in checking is 10%. Again, the most interesting thing on this T account is right here, the step when Bank B created some new money. Money that didn't previously exist, that they created by making a checking account for Jack. So let's put this money over to the side. Now, by now you get the point. I could go on and on. Bank C would have the same setup and the same numbers, only they would be 90% of these numbers. And Bank D would have numbers that are 90% of those. So by now, we're ready to ask the question, how much does the money supply change in response to that security that you sold to the Fed? You sold $1,000 security to the Fed, you got a $1,000 check, you deposited in your bank, and you set in motion a chain reaction. What's the total change in the money supply? Well, the total change in the money supply is going to be equal to, first of all, the money that came from the Fed. And the money that came from the Fed was $1,000. So we'll put $1,000 out here. Then there was the money that was created by Bank A when Bank A made that loan to Jane, and that was $900. So we'll put $900 right here. Then there was the money that was created by Bank B when they made the loan to Joe, and that was $810. Sorry, I think it was Jack they made a loan to, but it was the same amount of money. And Bank C creates a loan of $729. So we'll put it out here, and it just keeps going. Each number is 90% of the number before. Why? Because banks are able to lend out 90% of the new reserves they get. Well, that means the total is going to be 1,000 plus 900 plus 810 plus 729 and so forth. And if you add all of this up, Bank D, E, F, and so on for infinity, you get 10,000, 10 times the original amount of money. Now, how do we know that? We know it, first of all, because you could do it by brute force, just adding up the numbers forever. But the easier way is we've got a geometric sequence here. The geometric sequence is the net change in the money supply is equal to 1,000 times 1, which came from the Fed, plus 90%, which was created by Bank A, plus 90% of 90%, or 81%, which was created by Bank B, and so forth. And anytime you've got a geometric sequence like this, it has an easy, simple expression. It's 1 over 1 minus whatever this term is. In this particular case, it's 1 over 1 minus the fraction that banks are allowed to lend. And the fraction that banks are allowed to lend is 1 minus the required reserve ratio. In our case, the required reserve ratio is 10%, so the fraction that banks are allowed to lend is 90%. And that gives you insight into the money multiplier. The money multiplier is simply 1 over 1 minus the required reserve ratio, or the change in the money supply that results from a change in reserves, and that comes from anything the Fed buys, is equal to 1 over the required reserve ratio. So if the required reserve ratio is 10%, the money multiplier is 10. If the required reserve ratio is 50%, then it's 1 over 1/2, the money multiplier is 2. The bigger the required reserve ratio, the more money each bank has to keep in its own vault, and the less it can lend, the fewer new checking accounts it can create. The smaller the required reserve ratio, the more banks can lend, and the more easily they can create checking accounts, turning a small amount of new reserves into a big increase in the money supply. So if we take all those little pieces of money that we started with and add them up, here's the amount that was created for Jane, here's the amount that was created for Jack, here's the amount that was created in the next stage, and the next stage, and the next stage, until the pieces are too small to add up. The end result is the total change in the money supply. And the total change in the money supply is going to be the original change from the Fed multiplied by the money multiplier, which is 1 over the required reserve ratio.